Hi everyone, let's go over LeetCode problem number 100, same tree. Let's go straight to the point. So basically, we need to check whether or not the two given trees are the same. In order for them to be the same, they need to be structurally identical, which means that they need to have the same number of nodes, and the values of the node at the corresponding position have to be the same. In this example, the values of the root are equal. The values of the node on the left are equal. Same with the values of the node on the right. So in order to solve this problem, we need to compare each pair of nodes at the corresponding position. If any pair is not the same, we can stop right away and return false. Otherwise, we just go through all the nodes till the end and we're done. Because of the nature of this problem, the approach would be depth first search and recursion. Let's take a look at bigger tree and walk through the algorithm. If the values of the two roots are the same, the problem becomes comparing the subtree of each tree. So the subtree on the left of this tree is compared to the left subtree of this tree. The right subtree of this tree is compared to the right subtree of this tree. Each subproblem is further divided to even smaller problem. In this case, this tree is compared to this tree. This tree is compared to this tree. Similarly, on this side, this is compared to this, then this is compared to this. Such a pattern is a great candidate for recursion because we're broken down a bigger problem into smaller problems to avoid repeating the same step over and over again. Let's talk about the edge cases. If both of the roots are null, then these two trees are automatically the same. What if one side is null, but the other is not, let's say a values of 1, then right away we can return false. When comparing the two node values, if the two values are not the same, we can also return false right away. How about time complexity? In the worst case scenario, we have to visit each node exactly 1, so time complexity would be O(n). Same with space complexity. In the worst case, if we have to visit all the nodes and each node is visited exactly once, time complexity would be O(n). Let's see how to implement the logic in code. In the case that both roots of the two trees are null, automatically the two trees are the same. If this condition is not executed, that means one of the nodes is null, the other is not, or the values of both nodes are not null. So now we check if not P or not Q return false. Now we compare the nodes that have values. If the values are not the same, we don't have to go further. The last thing to do is to call the function on the left side and on the right side. Let's run and check the code. Great, and we're done. That's it for this video. I hope this is helpful. I'll see you next time and happy coding.